Hello everyone and welcome to part 3 of this tutorial series. In part 2 we set up networking so that we could see our friends move around. Now let's do something with our friends. Let's make it so that we actually have a race. In order to do that I'm going to check out part 3 so that you can follow along and see how to do that. Then I'm going to show the general scene and the configurations so some of the code that I show you will make a little bit more sense. And then I'm going to take a look at the code for the game mode, Gamestate, Playerstate, HUD and the widget, and then code for the triggers. I won't be showing the final product of this because that is shown in part 0 where I have a friend join and do the race. So if you want to see what this looks like at the end, go take a look at the start of that video. Alright, let's check out the correct part. If you've just freshly cloned, the tip may be at part 3 as it currently stands, but just in case, let's check it out. So let's go into where we have our Unreal project stored, and let's go into whatever folder you've named it. Let's do git checkout part 3. Alright, now we should be able to open Unreal. So if you go into here, if you're having issues, if you don't see the solution here, you don't know how to build this, check out the end of part 0 for how to build and handle issues when freshly cloning a repository. I've already done this, so I can open it up quickly. Alright, now that that's open, let's take a look at our game world. So as you can see, I added some little barriers to keep you from falling off. I haven't added those to the race course, so be careful. If you do fall off, you kind of get stuck and have to restart. If you want to add something for that, that's nice, but it would have been a little bit difficult. I don't think there's any standard code or standard meshes that could use to add that barrier. You could use squares, that's up to you. Add a little goalpost so you know when you've completed a lap. If you can see the faint outlines, these are all triggers for steps so that you can't go backwards around the course, or you can't just go back and forth across the finish line. So let's take a look at the details on those. So I have them named. 1 is start, and I just set the step to 1. And then 2, step to 2, and there's code that checks that you're coming from the correct step into each consecutive step. And that also handles lap, and that's in the player state. That code could be handled in game mode on the server, but I wanted to save how much content we save to the server and be a little bit less secure because I'm already doing client authoritative movement, so it wouldn't make much sense to make things more complicated and do client authoritative scoring. Although I do some of it just as an example, mostly for player ready. So this is the player ready box here, and this is just a visual symbol so that players can see where that's at. Alright. The only other objects that are of importance here are this little floating knob, which is lobby spawn. This simply tells the code where to spawn you when you're done with the race, so that it has coordinates for that. And you can move this around, and if you wanted to change the location of your lobby. Then there's also this race start spawn over here. So the code for this, let me bring it up, is really simple. It simply reaches into our game state and says the location of this should be race start for our game state. And that's under locations, under content. The way I made this race course is I just took a cylinder and stretched it. So if I drag out a cylinder really quick, you can just see me stretch it like that. Then I just simply set some of the basic skins from the starter content under materials. Okay, now let's look at our game mode blueprint and then the game game mode code. So this is the game mode for our actual race. This is the game mode for our menu that was shown in part 2. And in world settings, which is the settings for this particular level, you'll see that we have our game mode set to BP Racing Game Mode. Now the reason that I'm not simply setting it to the C++ Racing Game Mode listed here is that if I do that, I can't change any of these settings here, which is really nice. And there are certain settings that are highly preferable to be done here. Okay, now let's take a look at the code for the game mode. Open this up. Okay, so now that this is open, here we have our code for the game mode. This is only running on the server. So in a server authoritative game, this checks things like who wins at the end, and any decisions that would be bad to allow the players to state is usually handled in the game mode on the server. So we include some items here just so that we can set the defaults. There are a couple of other defaults that are set in the blueprint as I showed, but these are the ones that are set for C++ classes. This is just a simple function that made sense to have on the server. Check all ready, so each player, when they run into that ready zone, sends a message to the server saying they're ready. And this just goes through all the players, and if one of them is not ready, it'll return false. Otherwise, it will go down and tell the game state to start the race, and then return true. This right here is just an extra function. I had considered setting the race time on the server, but I changed my mind and had that run on the client. The reason for that is on the server, technically, in a competitive game, that's where you'd want it, but I was worried that if there was some kind of lag, one of the players might have an advantage in terms of their race time, so I allowed that to be handled on the client, even though it's less secure because I wanted it to be fairer if people aren't cheating and not rely on network speed for your race time. You can get around that with a ready, set, go that's handled properly, but I didn't want to add all that extra filler code. Check all done here is the counterpart to check all ready. So once all the players have crossed the finish line, this decides the player place. So, if you got first or second or whatever, and then calls the game state and tells it to stop race. This doesn't currently have any code in it because most of it is handled right here and then in the player state. But if you wanted to do anything like spawn fireworks or do anything that needs to happen on every single game instance that's not directly related to the player, then this is where you'd call that. So it seems like most of our calls here are either to the player or to the game state. So let's take a look at the game state next. Game state is not extended by a blueprint in this code, so there's no corresponding blueprint for this. So here's our game state. This could all be called from the player controller if we wanted to, but I left it in here because this is the correct flow to go from the game mode to the game state to the player controller. At least that's what makes the most sense to me. So this start race teleports the player to the start and sets their rotation and then tells the player state to start the timer. Additional things you could do in this function would be if you had code in your race that you didn't want running until you had actually started, like it was performance intensive and you just didn't want that to be running while people were in the lobby, you could start that here. Or something, a bridge that opens at a specific time to allow people who are behind to catch up. Or whatever it is that isn't necessarily specific to the player, that's what you would call here. Now, for the same reason I left in this stop race implementation. Even though I'm not currently calling it because I'm handling it in the game mode in the player state, I left it in here so that if you wanted to add anything on your own, you'd be able to do that. And this is called and set up to be called at the correct time. Let's take a look at our header file really quick here. Note that we have another net multicast, which was explained in part 2. Reliable because we don't want to accidentally drop and only have one of the players start the race, and this forced with validation. Same thing with stop race. We wouldn't want anything to only happen on one of the clients and not the others. And then these are values for where to put the player, and these are set from our blueprints that were shown earlier. All right, the next thing to take a look at, as this is calling the player controller and the player state. We've already gone over the player controller in previous videos, so let's take a look at the player state. All right. Here we have some includes. You can take a look at those if you like, but there's not much to say there. We configure so that the player doesn't start out ready or start out complete with the race. This is where you can change the amount of laps it takes to win if you want. And this is a default so that you know if they've crossed the start line or not. And this is what lap they're on. Total steps. This needs to match the amount of steps that you've dragged out onto the course. This is our tick statement. Here we're simply calling our widget and telling it to show the time if the race is running. That's all we're doing in the player state. Tick. This is a function to start the timer. And we also get a reference to our widget here rather than getting it at the start because I was getting crashing issues if I tried to get it at the start before it had properly loaded. Stopping the timer just simply sets that variable to false, that this function no longer increases the amount. This is telling the server that we've completed the race. This simply tells the server that we are ready. So this calls the game mode check already, and if everyone's ready, the race will start. This is a simple function that allows other code to set the place of, to change the widget for the player, and that's called from game mode. This is just a simple getter for whether or not the player is ready. This is for replication. This isn't technically needed because I explicitly set the ready and done values. I think you could get away with this. I'm not 100% without this, but it made sense to have this here so that you can see how to do replication, as that's common to a lot of multiplayer games. Our begin play here, I'd forgotten that I'd done this, but this automatically sets mtotal steps to the amount of triggers that we have rather than us having to go and explicitly change this. If you wanted to have branching paths where you could set 3 in multiple places, you'd have to get rid of this code and then find another way to set it, or set it manually above. Set step. So this is as the player is going around the course. They start out at 0, then they cross the start line, sets them to step 1. And then if their current step equals the total steps. So if they've gone to the fourth step and the step that they've just been set to is 1, then we've done a full lap and we set the step, increase our laps, and then tell our widget to increase the laps. This is a check to make sure that when you're setting a step, you're coming from the prior step, and then this is to end the game if you have completed the desired amount of laps. So that's all there is for the C++ file, the Playerstate. Let's take a look at the header file. Again, we just see some client reliable. This is so that this can be called from a blueprint. This is an artifact from when I had the ready zone as a blueprint. I've moved that to C++, so this is no longer needed, but if you did want to have a blueprint, you'd need this here to do that. All right, then just have some basic declarations. You need replicated for replicated variables, as I showed in the C++ function. I had considered reading these values directly from the widget, but I decided against that as it made more sense to have the content flow downwards to the widget. So this isn't needed, but that's how you would do that if you wanted to do a read for your widget. And then this is a reference to our racing widget, which is set. Okay, now that we've gone through the player state, let's take a look at our HUD code. Bring this down. This is pretty bare bones. The reason for this is to have this as a bay for your widgets rather than having your widgets created directly from your controller. You can have them created directly from your controller. I just thought it would be nice to have a place where if I needed any extra logic relating to my widgets, handling them, showing them, hiding them, I could do it in here and it wouldn't be cluttering up my controller. That's why I have this code. This simply at begin play creates the widgets, adds them to the viewport. Header file. So for the HUD, you need to set this widget so that you can choose. So you can choose between 2 different types of widgets if you wanted. Now I have hard pointers to this that cast it in other locations, so that's not exactly true, but that's the general idea. If you had an interface, you could choose between multiple different widgets. I didn't have multiple widgets, so I didn't need to set up the interface. So let's take a really quick look at what the HUD blueprint looks like. Notice there's almost nothing except you go to class defaults. You'll notice that I set the mRaceStats widget to BP Racing widget. So now that we've looked at the HUD, let's take a look at our widget code. There's a C++. If you notice, that was a blueprint, but it's extended from a C++ class. So let's take a look at the C++ class. So here's our racing widget. This just simply has some set times, or some setters that allow you to set the time, set the lap, and set the place. Notice this meta bind widget. I will take a look. I'll show you what exactly this does in the blueprint for the widget. But the idea is that if you set the name of a widget, of a item in a widget, then it'll automatically be assigned to this value in the C++ code. So you'll notice that I've named my lap text lap in my widget that I'm about to open, and then my time, I've named it time, and then the place has been named place. So let's take a look at that. Blueprint code. Right. Content. User interface. Widgets. BP racing widget. And on the left here, you can see this title is time, but the actual lap value, this is what gets assigned to that header file, to the C++ code. So that's what we've set here up at the top. This lap down here, the variable is text lap and the text is lap, but this is not the value because this is the actual text, the word lap. The value is what needs to be named lap for this to work properly. Okay, let's take a look at our graph. You'll notice that there's nothing here. That's because all of this is called directly from the C++ so that we have good performance. And widgets are fine if you don't have anything in the graph in terms of performance. So that's what I went for here. The last piece of code I need to show here is the code for the triggers. So let's go to our C++ code. And let's take a look at race ready trigger, because that's going to be the simplest of them. All right, so we set up a simple collision, just name for the collision profile. This actually sets some things. This is an Unreal default. Then we set it as a root component, and we add our delegates that are then called when something begins to overlap or stops overlapping. So when we begin to overlap, if what we overlapped with was a rolling ball and the other actor isn't this trigger and the other component exists, then we will tell the server that this player is now ready. That's all that's happening in this trigger. We can take a look at the header file here. These delegates need to be U functions. That's another important thing. So let's take a look at our other trigger now. This is the trigger for the steps to make sure that the player goes around in the correct order. Most of the same setup as the other file. Only thing that changes on overlap begin. We set the step to whatever the step attribute is of this trigger. These aren't extended by blueprints. These are just drag and drop out from the C++ code. If you wanted to have some more settings be available to you, like changing the shape of the trigger or other things like that, then you would want to extend these with blueprints. In this case, I've already hard set it as a box, so I don't need to do that in this case. With that, that's everything that you'll need from this tutorial. That's almost everything there is to explain about this. So thank you for watching, and I hope you learned something.